Hey everybody, getting things set up and started, and I'm gonna jump right in as soon as it's up. Okay. Good enough. Hey everybody, I'm Jeremy Miller. I'm the technical lead of the Critter Stack tools, and also the founder and owner of Jasper FX Software. That's the company trying to put a business plan around the Critter Watch. Today, this is going to be real loose. Everybody grab in questions anytime you want, but I want to talk through some of the work that's ongoing with Wolverine 5.0. I think it'll actually be out at the end of this month. But there's actually some pretty cool, I think some exciting stuff people are going to actually want. So we'll get into it. First question is, why in the world are you doing a release so soon after 4.0? And I will admit this is not ideal. I'm not super thrilled that it came this fast, but we are the top line bullet here. Let's see. Long story short, to follow the stream of actions, one of our clients was able to prove out. Sorry, my dog is gnawing on my Crocs next to me. I wonder if I need to take them away. One of our clients actually hit a problem, was able to demonstrate a flaw in Wolverine's underlying use of the TPL data flow library, where its sequence guarantees were not really guarantees under heavy load. Kind of a problem because that's a crucial feature for what they need to do, and it's a crucial feature for a lot of things other people wanted to do. We have kicked around for a long time the idea of moving from TPL data flow, which Wolverine and Marten both started with 10 plus years ago, to system.threading.channels. That's a much newer library, probably better maintained. We know that it has significantly faster performance. So knowing that we wanted to make that switch to deal with that problem, and then also I wanted channels underneath that. The first feature we're going to talk about, bite the bullet and do it. I could pleasantly say it took about 2.5 days, all told, to go from nothing to having both Marten and Wolverine running with channels. I'll blog about that soon. It's not completely released, but I just want you to know that it's there. We felt, talking that over with some of the other core team members, and they agreed. This is a big enough change that it justified flipping up to 5.0. That also means it opened the door to take care of a few other potential breaking changes that we didn't get to do in 4.0 because it was a really rushed release. What I can tell you is there will be very, very few API changes from 4.0 to 5. I'm only aware of one. Some places where it did allowed you to do explicit configuration of TPL data flow, and that doesn't exist anymore. So I guess long story short is I'm expecting a very smooth transfer from 4 to 5. I don't think it's going to be the slightest bit harder to go from 3 to 5. I think we're fine. Okay. On that one, oh, dadgummit, dog broke my. The first thing I want to talk about, and we landed on the name, Partitioned Sequential Messaging. I just want you to think of a world where, a very common world where you're pumping a lot of messages into your system that may be trying to modify the same identified entity at the same time. Happens a lot, unfortunately, with event sourcing. Excuse me for a second. So Marten event streams are unfortunately a little bit susceptible to concurrency. The way we're trying to rev a version on the stream every time you append events. It happens very frequently with users. Maybe there's a burst of messages or activity that hit one stream at a time, and you potentially get concurrency exceptions being thrown. worlds of protection in Wolverine to do retries, to do optimistic concurrency checks, all kinds of ways to make your data safe, but you still got to deal with it. It's still annoying. Or maybe you're working with a Saga. You were a Saga that's doing some kind of scatter gather. Hey, boom, I'm going to go release a whole bunch of messages that are going to go gather up work and come back and try to change my Saga. That's a place where you potentially get concurrency violations, trying to edit and modify the same Saga, different nodes, different queues. I mean, hopefully you see where this is going. Okay. So we have been talking, Jasper FX, we've been talking with one of our clients for quite a while, and amongst the core team and with other potential clients, what if there was, hey Ross, what if there was a way where Wolverine could segregate the work for you automatically such that it could parallelize work overall, but it could make work within a single stream or Saga ID or some random user-defined categorization of messages? They could go single file. And that's what we're going to get to with Partitioned Sequential Messaging. It's the working name right now. I think it's the best we've come up with so far. So let me finally dive right into code. Because I think this is the single biggest advance in Wolverine 5. This is why you care. So first off, I'm going to show you a local test. We're going to stay completely within one node. We're going to only worry about local processing right now. But the test harness, what we're doing is we're going to throw together like 10 parallel tasks, and we're going to hammer it by trying to publish messages that would try to append. This is all pretty crude. It's all trying to append events to a stream. But what we're going to do is we're hammer it in parallel. So we're throwing a bunch of messages for the same stream all at the same time and see if we can get through without any concurrency exceptions. So let me look at the first test. Let me show you some of the things we can do here. So if we're going to do it explicitly, a little bit of new syntax here. I can tell Wolverine, in this case, based on some kind of marker interface on the message type, just pretty similar to how we do things with some of the middleware application. Hey, here's how you group messages. So this is determining the group ID of a message. What that's telling Wolverine now is how to categorize messages coming in so it knows how to segregate them later. Coming down below, actually, the syntax got a little bit cleaner as I went. Let's So in one place, I can now say with message partitioning, by message, I want to publish everything to, we're going to rename it real quick. We're going to publish everything to this partition local messaging. Base name of letters, I want 4 slots. And here's a little bit, I'm going to kind of tell it, how are we going to route messages around? This one's important. A couple things going on here. We got actually 2 levels of parallelism. So the first level of parallelism, letters and number of queues 4. So what this is going to do behind the scenes, it's actually going to create 4 different local queues. Letters 1, 2, 3, 4. Within each queue in its own handling, it's going to allow for a maximum degree of parallelism. There are, I'm going to say there's five different slots active. So we back up and explain what this means. So here, as we're battering these log messages, throwing them in as fast as we can. It's a little letter message. It's just telling us what's the event stream ID in this case. Hey, I want to partition this by ID. And it's working exactly the way you probably already guessed. Coming into the queuing, when you try to message out, the routing is going to say, oh, you're this kind of message. You're going to go into one of these slots, these four letter slots. I'm going to take the group ID that you taught me how to do. I'm going to get that value as a string. I'm going to do a deterministic hash to an integer. I'm going to do a modulo 4 on it, and that's going to tell me which of the slots, 0, 1, 2, 3. That's going to distribute the load into one of 4 different local queues running. Because it's deterministic, every message related to a single stream is always going to deterministically go to one of these slotted queues. Okay, I mean, so far so good. If you've ever worked with Postgres partitioning, that's how that works. If you're coming from Azure Service Bus and you're saying this sounds very similar to Azure Service Bus session identifiers and FIFO queues, yes. Same context. Now, within the queue itself, local queue itself, as it's getting messages in, we do a completely different set of partitioning based on the ID coming in. Except in this case, it's using a different deterministic hash, just for Trivial Pursuit. It's actually a Java compliant. It's using whatever the Java algorithm is for deterministic. But it gives you a different value for the deterministic hash than the original publishing. So even inside the local queue, over 5 different slots. So there's going to be 5 different channels running messages. It's going to, again, take that message name, a message group. It's going to do deterministic hash. It's going to do the modulo thing. And then it's going to spread it out over a single channel within the greater local queue. So this is going to give us even more parallelism within the local queue, but you're always guaranteed that any message for the same stream is always going to end up in the same local queue and the same channel within that local queue, so that such that it's running sequentially. And the test here, let me show you this real quick just to prove that this works. It's coming. The point here is this test would fail if any exceptions are thrown in the background at any point. It's just using basic, the built-in Wolverine test helper. Everything's compiling. But long story short, we'll come back to this. When I was building the test, if I run this without the fancy meshes partitioning, then the whole thing just fails because it'll throw tons of concurrency exceptions. I mean, Wolverine's got the ability to retry it. That's great, but I mean, it's still annoying. You still have to retry it, and anytime you throw an exception, handle an exception, retry. I mean, that's work. It's work on the system, and then people who aren't necessarily as sophisticated about retries may miss that, and the system falls down. Just kind of another Trivial Pursuit thing, the maximum degree of parallelism. This is it's an enumeration, even though it's numbers. What I found out is by partitioning it once and partitioning it second, the only way to consistently get a good spread for the second stage is if you were using an odd number of slots. So this shard slot thing, this just forces it to be odd for you. I mean, sooner or later, as a developer, you run into enumeration that's 1, 2, 3, 4, whatever, and everybody laughs at it and makes fun of it online. You remember when the daily WTF blog was a real thing? So there's my entry for the daily WTF. Moving to showing that this works, here's the exact same set of tests, but doing with RabbitMQ. This does pass. It just times out real easily. Same kind of thing. We're going to publish to sharded RabbitMQs. Same kind of thing. So there'll be letters 1, 2, 3, 4. When we get this documented, you will probably want the number of endpoints to be either equal to the number of running nodes within your system or a multiple of the running nodes. In the case of remote, using a remote queue, and so far I've built and tested this with RabbitMQ and AWS SQS. We'll add it for everything else before we're done. What it's doing is it's making each letters 1, 2, 3, 4 queue. It's telling Wolverine, hey, this is an exclusive queue, which just means, hey, Wolverine, I only want one node across your entire system to be actively listening to this queue. That's a feature we've had in Wolverine for about a year. Wolverine is doing some leader election. It knows what the leader is, and that leader is assigning how does work get distributed. As nodes come up and down, Wolverine is going to be trying to ensure there's kind of an even spread of letters 1 is running here, letters 2, letters 3, letters 4, all across different nodes within your clustered system. So you have some level of load balancing. But even inside each listener, which, it's only running in one queue, you can also kind of pump up the allowed parallelism within that one listener. So the whole end result of this is you can pound a bunch of messages through that would be prone to concurrency errors, but Wolverine can kind of organize, sort, and sequence them in such a way that it doesn't actually hit concurrency exceptions. It's going to make your systems far, far more resilient to concurrency issues. But wait, there's more if you act now. Let me just built this yesterday, so I don't remember. I've already forgotten what the API is called. Yep, there's you. All right. So if Pascal Sin is on, happens to be on this, Pascal, this is for you. This is something that Pascal Sin from Chili Cream had suggested. Now, the inferred message grouping here, what this is doing is it's saying it's kind of just utilizing things that Wolverine probably already knows about messages. So any message that is dealing with a saga, it's automatically going to be able to see, oh, you're this saga type. And it already knows what the identity of the saga is on the message. So the inferred message grouping, when this is turned on, if you were dealing with messages related to a saga, that's enough. It can already do the grouping based on saga ID for you. There's no additional work to do. That's pretty awesome. One of the use cases, concrete use cases that brought this whole thing up was kind of a control process on a long-running saga that was just coordinating long-running workflows for inevitably importing files from the outside. When you have to do those multi-steps, break it up, validate it, go call this external web service, come back, all that kind of thing. That kind of saga was it's very prone to concurrency problems. So it was really important in this case to run things sequentially to stop all concurrency problems. But then you end up in this, what they were doing was running strict ordering, which only meant it only could run on one node and only one saga message could be processed at a time across the whole system. It's an obvious bandwidth problem. It's not a serious problem for them yet, but they assume that it will be. So we get this. The other option is just complaining about all of the aggregate handler workflow stuff coming in. that process already knows what the event stream ID is based on just what it does anyway. So go use that information to do the automatic message grouping for us, such that you can make all messages for a single stream run sequentially while being parallel across the whole system. That's a whole lot of words, but this is the single biggest new feature in Wolverine 5, and I think this is the single biggest reason people are going to want to pick this up. So we're really excited about this. It's something people have been asking for a long time, or we've been talking about amongst the core team for a long time. So I'm really excited about this. It's not documented yet. Will be soon. I'm sure the APIs will adjust a little bit in the meantime. All right. Let me just remember what to go on next. Okay. Let's talk about interoperability with Wolverine. It's a complicated world. We're kind of the new kids on the block. You're going to need Wolverine to be able to talk and interact with systems that are not Wolverine, maybe not even .NET. So there was a pull request open about 2 months ago. Man, feel terrible how long it took to get to this, but just, hey, Jeremy, folks, we had some trouble creating custom interoperability. Yes, there's a plugin point, but some of the things in Wolverine we needed were internal. It would have been nice if we could have started with the base envelope mappers and just configured them a little bit in some cases, so on and so forth. We started up a GitHub issue for improving interoperability on Wolverine, and got a lot of feedback from the community of things that they wanted or needed or would like to see. And I really appreciated how much that feedback came in. So I think wrapped up this work early this week, but maybe just talk about this a little bit. So there's going to be a new tutorial in the Wolverine docs when 5.0 is released. Don't go looking for it right now. This is running locally. But talking a lot more about how the interoperability works, what are the bare minimum requirements if you want to run totally custom mapping. We've got easier recipes to build and apply custom mappings based on some of that earlier pull request work. And then we have a lot more built-in interoperability mappers than we did before. So hope that's legible. So let me talk about a little bit of what's new. Now we have, from the very early days of Wolverine 1, we have had interoperability with supported interoperability with mass transit and in-service bus through RabbitMQ. That was done from the beginning. Actually, that was done for the shop that I was in 4 or 5 years ago to make sure we could actually use Wolverine. Today, that is now extended. You have the built-in mass transit and in-service bus interoperability for Azure Service Bus and Amazon SQS now. With Amazon SQS being the weirdest single thing you can use. And even though it's from the same people, you also have interoperability with mass transit and service bus for the newer Amazon SNS transport. But the code's a little bit different because the model's a little bit different. Thank you, Amazon. That's all out of the box. And then a handful of people over time, but enough to pay attention to, have asked about the cloud events specification. I really don't know how pervasive that is or how much it's actually used in the real world. Microsoft's Dapper tool is the only thing I know of for sure that uses it, but enough people have reached out of interest either using it. One of our core team members, they use cloud events in their internal systems. So it was worth the time to go ahead and put that together. I'll show you what it looks like. It's not a whole lot to it. For RabbitMQ on endpoint and by endpoint basis, you can set up endpoint policies. So just say, hey, I want to interoperate with cloud events. So if I'm sending messages, it's going out as cloud events. If it's coming in, I'm expecting to read it. For those who haven't been exposed to it, cloud events, it's just a standard of wrapping messages inside of JSON body. So there's a JSON envelope that has all the metadata about the message, and you're assumed to have a node called data that's the actual message inside of it. So that went pretty smoothly. So we have cloud event support across everything. Come back here. Yeah. So it's tested against Kafka, Pulsar. It's admittedly probably experimental against MQTT, but we have the support there. Any questions about the interoperability, or I don't know if there's any things I missed there? While I get a drink and rebound. So the cloud events also turned out to be helpful because we're going to use it right off the bat for the SignalR transport. So kind of bumping into that a little bit. So people have asked about a SignalR transport off and on for a couple of years. I always said, hey, I think that sounds interesting. I don't want to do it yet because I don't know what that means. We need concrete use cases, so on and so forth. Well, now Jeffrey Gonzalez and I are actively working on CritterWatch. So it is going to use the SignalR transport right off the bat. Looking at the picture, the working theory, and this works heavily in flight, going pretty well, is we're going to use cloud events wrappers to send messages back and forth. So if you have an application that's going to have a significant amount of interoperability using WebSockets or all the different things SignalR supports, server-side events, all that good stuff, Wolverine's going to put a little bit of infrastructure so that you can blast out every possible type of message that it knows about across the SignalR channels, the cloud events wrapper, and it could be as simple as I have a JSON wrapper that has a type element that just tells me what type of message it is. It'll probably be kebab case to be JavaScript friendly, and it'll have a data element that's the actual message. The SignalR transport receiving messages, it's able to pull that apart, know what the .NET message type is within Wolverine, build a Wolverine envelope, and then after that, it is normal Wolverine. So every possible thing you can do with message handlers, you can do. You get to retry. You will, if somebody on the client side really even wanted to send correlation and causation information in the cloud events mapper, you would get that. So you could build up open telemetry tracing between WebSockets being sent from a browser all the way to Wolverine, all the way to other Wolverine apps. So that's on receiving. On the sending side, same thing. It's going to be able to, you'll be able to route that, hey, I want this to go back to a SignalR hub. It's going to go down in a cloud events wrapper, same thing. I know this is I'm like 10 or 15 years out of date on my JavaScript, but I am so old that I used early React and Redux when it was the newest, coolest thing. That one thing that was worked really well was WebSockets sending message in, just feed it right to the Redux store or whatever the equivalent is now. You guys are laughing at me because there's like 5 generations past that. But that kind of application architecture worked out really well way back then. I think we'll do something very similar on CritterWatch because there's so much interactivity. So that's all the easy stuff. The harder stuff here is considering, well, I want to send a message to SignalR, but I want to be able to send it to a specific user, or I want to send it to a group of connections, right? And then also, as connections are coming into SignalR, I'm going to want to be able to categorize those into groups somehow. And we are Wolverine, so still want to have pure functions as much as possible, right? So let me hop into some of the SignalR stuff. Before I do that, Tony, your question, the partition sequential messaging request reply. Yeah, I think we could make that work. Wow, I haven't really thought of that. That's kind of nasty. But yes, that's technically possible. Maybe weigh in on that. Yikes. Let me switch to SignalR just a little bit. Let me just show you some of the things I'm thinking about. So, like one of the things you might want to do, if you're familiar with Wolverine's side effect model, this isn't tested, where you can just kind of return out from your nice pure function of, hey, I want this action to happen. Something that's probably inconvenient for testing. I want you to write to a file. I want you to write to an S3 bucket. Something that's kind of icky inside of a pure function, but we just want to decide to do this. Kind of working on a way that you could return out a side effect that just says, hey, this current connection, I don't know anything about the current connection inside of my message handler, but if I return out the side effect, the mechanics behind it being able to kind of peek in and say, oh, this message came in off this SignalR hub, and I know what the current connection is. I'm just going to do this for you. So being able to add messages to groups, being able to take connections out of groups, it's going to be important right off the bat with CritterWatch, where folks maybe I'm listening to this project, this monitored project, that monitored project, but I can see this is going to come up pretty easily in dashboard applications with SignalR. Being able to route things around. Things like being able to do a little bit of a wrapper of, hey, I need to send a message. I just received a message inside of Wolverine, and I want to respond to the current caller. We have some functionality to do that today for normal messaging, but SignalR might be a little bit different to make it a little more clear. I'm not wedded to any of the naming conventions. We can get this in here. Yeah, I thought I'd change that. So there's a little bit of stuff where it can be smart enough by using response to caller. You can return this as your cascading message as just a declaration. Hey, I want this message to go back to whoever the caller was. This thing is going to use some Wolverine magic to figure out, what was the original connection. I'm going to send it back to you. Get into this a little bit. One of the things that's going to be hard for us with CritterWatch right off the bat, but I could see this with other people, is first feature up for us is dead letter queue administration. So you may be sending a query from your browser to CritterWatch of, I want you to tell me about summarize the dead letter queue messages for service 3 or service 4. So it's going to bounce from WebSockets to CritterWatch. It's going to bounce through Kafka over to this service. The response when it's ready, to make this as efficient as possible, I want everything to be asynchronous. It's eventually going to send a message back to CritterWatch, and CritterWatch is going to need to blast it back to the exact connection who wanted it in the first place. So one of the things I'm working with is I think I have a working strategy of how to smuggle information from here to here to here and all the way back of who to call back. I think we're actually going to utilize the Saga ID. And the Saga ID is going to have a meaningful connection equals ABC or group equals DCE, so that when it gets back and you try to send this message, the reply back, the SignalR transports can be smart enough to see, from the Saga ID, if it exists, that's actually going to tell me how to select the SignalR connections to send it back. And it's going to help you track almost kind of like a routing slip of this is where this needs to go back to, even though it's bouncing from here to there, back and back. I don't know if that makes a lot of sense yet, but I mean, hopefully there'll be documentation by the time this hits. The Critter Watch is one, we have to have this to build Critter Watch, but it's giving us real use cases to know what to do with the new SignalR transfer. So this is heavily in flight. I'm actually going to go back to working on it after this live stream is over. Just a few more things. I'm definitely going to quit before the hour is over. Wolverine HTTP and IoC. This came up quite a bit lately. Sure what I mean. All right. So we've got a few new additions to the IoC support for HTTP. The first one, and just so you know, so y'all know, as kind of the administrator of all this stuff, I do listen and pay attention to trends that where are we getting a lot of feedback, and it felt like all of a sudden we had a little cluster of questions around how do I pull information from the request services inside of HTTP context. So just thinking of ASP.NET Core services. There's a lot of middleware where it will pull a service out of IoC, and in some kind of scope dependency, it'll do something and smuggle information so that deeper inside the middleware chain or all the way to controllers or now into Wolverine endpoints, you can go into that same scope service, pull out this data that was smuggled in and work on it. Right? I think it makes for really confusing code that's hard to reason about. And when people gripe about IoC is so confusing, I hate IoC, I think that's exactly the kind of thing that causes people problems. But there's a lot of ASP.NET Core tools that use that. And we got to live in the world that we have instead of the nice Wolverine only model where IoC would. Up till now, IoC is completely isolated within the Wolverine HTTP endpoint. It has nothing to do with HTTP context request services. It just does its thing. And even more so, it even tries to not use the service provider at all. But some folks were needing to pull services out of the request services. So got to catch up on the documentation. A couple improvements we got in here. Couple new settings. The first one I want to talk about, the traditional Wolverine mode is Wolverine plays completely inside of its own walled garden. If it absolutely has to use a service provider to do service location inside an HTTP endpoint, it's making one for itself. It's closing it. It's managing everything. It has nothing to do with the rest of the HTTP context world. There is a new model, and because this is such a big change in behavior, this is an opt-in model. You can now say, hey, I want, when I'm building a map Wolverine, I can now say, hey, I want the service provider source to be, just use the HTTP context or request services. So you can share scope with whatever crazy, wacky ASP.NET Core middleware is doing. Like authorization authentication does that pretty frequently, or multi-tenancy detection. Wolverine has it built in, but there's a lot of other tools that do this by smuggling things through IoC. The point is, you can live in the world that ASP.NET Core actually is instead of only living in Wolverine's walled garden. Hope this is going to be more useful for more people. Another setting, can go back to where we are. I think this is new declaration here. So for longer term Wolverine users, the Wolverine works very differently with an IoC tool than everything else. Wolverine is trying really hard to not use IoC at all at runtime. What it's trying to do is look at the dependency tree and generate code that mimics what the IoC container would do for the most part. So that, the fastest IoC container is no IoC container. That's the theory. And it also tries to inline singletons, just do every trick it possibly can to reduce object allocations and low-level optimizations. But sometimes it absolutely has to drop down and use service location, which just means iService provider dot get required service here and there. And when that happens, there's potential for Wolverine, some of the Wolverine code generation, they get confused. Maybe you end up, even though we tried so hard to prevent this, maybe you end up getting 2 message buses in the code. Maybe you get 2 Marten document sessions. Maybe you get 2 EF core DB contexts. I don't know what it is. A little more fine-grained control, where default is we're going to allow you to do that, but we're going to warn you through logging that you are, just to call it out in the startup console output of, hey, this is happening to you. Are you sure you want this to happen? Just kind of letting you know this may not be a good idea, blah, blah, blah. You can also say a little bit harder. You can say, hey, I know what I'm doing. Shut up. Always allow this. Or you can set it a little bit tighter. I don't want this ever to happen, because if it's happening, it's an accident. Some new developer on our team we don't trust yet didn't know and did something silly. There we go. This stuff's all a little bit of compromise around Wolverine's unique model. Hope this is going to help. Another little feature it has. Let me see. It's been a minute since I've worked on this. But let me see. Never mind. So one feature we either have, and I don't recall, or we will have, is just your ability to mark, hey, this one particular service, I always want it sourced from the HTTP context.request services, even if everything else is isolated. That's something that's coming up. It's usually like multi-tenancy is usually the example of, maybe there's like some kind of iTenant context that's built up by middleware before Wolverine gets it. And I just want to pluck that out of the request services and use it inside my Wolverine guy. So that's enough on that. Get a little short on time. This guy, let me talk a little bit about this. If you follow event sourcing outside of Marten, it's mostly coming from the Axon IQ people, but everybody else has picked up on it. There's this idea called dynamic consistency boundary, DCB, kicking around. Won't get into it too much. I don't think it's really very applicable to Marten, but it's getting really hyped up, and we want Marten to have. I want Marten to have a good story, really the whole critter stack, to have a good story kind of back at, here's what we do instead. You don't need that. But first, kind of application of that. Yeah. There's a blog post about this. Let's say that you are doing something in a Wolverine handler that needs to work where you're declaring more than one data dependency in Marten. In this case, I want to work with the event streams of more than one account. So this is making one call through Marten to get a piece of data. And then it's making a completely separate call to Marten to get the second account. But this could even be crazier if you're using, there's a lot of other attributes to load documents or get a read aggregate of something, or we're going to extend this even further with more little declarative Marten helpers. But what I want to focus in on is how to make this more runtime efficient. One of the things that absolutely kills enterprise-y applications is just being chatty, making too many calls to the database. Today, the code you're looking at here underneath is going to make one call to go get this account, second call for this account. If I created a third reference, something like, something like this, where even, now I have a third requirement of something I want Marten to go get. That's a third round trip. Some of the last features we want to put into Wolverine 5 is make the Marten-related source generation smart enough that it can opt into Marten's batch querying. So no matter how many things you do, and maybe you do it in before methods and validates, but when Wolverine looks at your handler and all the things that are declared, if you are requesting more than one piece of data from Marten and Marten knows how to do that with batch querying, it'll generate code that does batch querying with Marten. The whole thing being, how can we get all the data, batch up the requested database, make fewer network round trips? We think that's going to be a huge performance improvement, and that's the performance improvement's going to be nice. And then I want the bragging rights to go back at other event sourcing tools and say, haha, look what we do, and we even do this more efficiently. All right, switching back to questions. Tony, to your question, yes, absolutely. You'll be able to use, yes, you can use different types of event streams. So the aggregate there is really a marker to Marten. It doesn't really care. And Marten's always been able to give you transactional consistency across more than one stream and one operation. You even have optimistic concurrency against both at the same time. There's a few hiccups about that we gotta sort out, but Tony, to your question, yes. Slider house rules. Hey, I'm actually going to probably need to ask you go look at the documentation for Marten's fetch for writing to get a better detail. But this event stream here, or when you use the aggregate handler workflow in Marten or with Wolverine and Marten, it is 100% taking into account for Marten's version of snapshotting. So it's kind of wallpapering over. For any given aggregate, is it set up to be perfectly live where you build it in memory? Is it running asynchronously where it's stored in a database but a little bit behind and we'll advance it? Or is it completely in line so it's perfectly consistent? The fetch for writing mechanics that this hides over just totally hides that from you. It just makes it work. This is consistent data. It can use the snapshotting optimizations. That's something I'm really proud of. That's something I think is really kind of awesome in the Critter stack. And there's absolutely nothing else in the .NET world that even comes close to that, in my opinion. So you walked into that one. Just a couple more. Okay, last thing that you see, this is a question mark. So we'll get to this at some point. Work on optimized cold start times. It gets us a little bit closer to AOT, which is not happening in 5.0. I have no idea when it's happening, but it's probably going to be generating more code as part of the pre-generated mode, where trying to eliminate any need to do like assembly scanning to find where are pre-generated types, or what are all my handlers, or what are all my message types. But just all the places today where you do assembly scanning to go discover things. What we're thinking the optimized cold start time when we get to this is a pre-generated mode. Probably builds out some kind of partial class that can alternatively load all that stuff up for you explicitly instead of having to do any kind of discovery. And I know from other folks who have measured this, especially in big systems with a lot of dependencies, the assembly type scanning can be an expensive part of the cold start. So that's something we're looking at. I haven't done any more work than the ideas kicking around we just talked about. So I strongly suspect this may fall off of 5.0. I think my personal and the Jasper FX priority is probably going to switch almost completely to CritterWatch soon. But these 5.0 changes are to support that. One last bullet item I really definitely want to do, with the changes from data flow to channels, I want to do some pretty hardcore measurement of performance and throughput of both Wolverine and Marten, especially together, and maybe do one more round of performance optimizations. Where are there places we could use spans instead of byte arrays? Where could we throw in some object pooling? Like, could we do pooling on the string builders that are underneath Marten that generate SQL? I would like to do that. I mean, as you all know, that's who knows how much work that will be. That could be a morass. But timing wise, I think most of the big feature work will probably be done by the end of this week, definitely by the middle of next week. I'm probably still saying that Wolverine 5 probably releases the end of September. Not in a massive hurry for it, and I'd like to kind of get it beaten on and test it a little bit. And then it takes a long time just to catch up on documentation. So with that, got a few more minutes in the hour. Anybody want to slide in with any new questions? Doesn't have to be anything we talked about. And I should say, this is I think this is the 5th, 6th live stream we've done so far. Didn't mean to be this way, but this is probably the one I had the least amount of time to prepare for. And it's also the biggest audience, and thought this went smoother. So maybe the new key is just to come in really loose, like a band that purposely doesn't practice a song so it sounds loose when they play. Hey, y'all. Hey, everybody. Thank you so much for coming in. The recording of this will be up almost immediately. And hoping any feedback you have or requests about some of these big changes, please throw it in. And guys, everybody, thank you so much for being here. Talk to you soon.